So today I want to talk to you a bit about declarative UI programming, which has been kind of my job, hobby, mission for the past 2.5 years. And well, it's a relatively broad subject, I guess. So the first question is like, what is actually declarative code? Because yeah, people like to throw around big words. But I would say that it's code that really makes your intent come forward rather than the way by which you accomplish something. You explain to the computer what you want, and then the machine, hopefully, can figure it out. At least if the guy who implemented the system actually did a good job. But even if it doesn't work at runtime, pseudocode, for example, is also very declarative in nature, or some sense. So it's also very good to communicate with humans, and that's what actually makes it really important, because it turns out that in our industry, nobody really knows what they want. Stakeholders usually don't. They use similes or some way to express what they actually want from you. They use software they know to draw comparisons. So they say something, I want something like Facebook with a bit of Excel in there and Counter-Strike. And then I need 3 buttons there and 2 there, but no, but I mean, it's a bit over the top, but essentially that's how communication with them goes. Okay, and the way to clean it up would be to write some technical documentation and requirements. Most people don't want to do that. The other one would be to actually have a software design in your language reflected that actually clarifies this. But usually that doesn't happen because programmers prefer to solve more fun and interesting and isolated problems that are more up their sleeves. They don't want to go into this whole vague territory even. And they hide in rather complex implementations, and it makes them feel like they've done much work, but usually this is not so. So the question is, I mean, this is all nice, but what tangible problem could we possibly solve with declarative UI programming? And the goal is essentially to iterate better user experiences with a lot less effort. That's the other side. If you don't care so much about the details, you get to iterate much faster. You get your results much faster. Usually this is done with designers and the clients, but then when they get the real thing, they realize that, okay, this doesn't really feel nice, so then the designer has to go back and get these long chains. And if you were able to do it in code, then you can speed it up. Like, you can literally sit next to the client, they tell you, I want this, 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 you can adjust. And it would be so much nicer, right? And so to understand what's main question is, what is actually UI? Well, from the user perspective, this is your software. There is nothing else to them. This is this is the thing. None of the rest matters. And for developers, it's usually just a nightmare for many reasons. One, they can't really put themselves in the user perspective, but also it's a very complex thing. Here's a nice tweet from Lars. Some of you know him, the Defenders Quest guy. And so, yeah, he says for a nice feature, he needs a few days and then a month to do all the UI that goes with it, or actually 2, as it turns out. So yeah, there seems to be quite a challenge to be tackled there. One of the ways to get a hold of the complexity is to split your application into a model and a view, into a business and a presentation layer, and so that you can, when you need to reiterate the UI, you don't need to throw away the whole thing. You get to keep your stuff. That's kind of cool, but congratulations, you now have a new problem. Your model and your UI are out of sync all the time because you forgot some update path or something. And I mean, almost every modern application has this somehow. So yeah, the most common pattern to somehow do this this synchronization between the two is via a lot of controllers. It's not really clear what that even means. Controller is just code that doesn't have anywhere else to go, I guess. I mean, I don't know. Maybe if somebody knows the definition, do tell me, please. And there have been countless attempts to fix it, like hierarchical MVC, model view presenter, modular MVC, model view model, all of those things. Very few of them really worked out that well. And you do a lot of stuff, and what you really get is you get usually a model layer that serves nothing. If somebody gets a reference to a model and updates it via a code path that you didn't predict, everything is out of sync. So you have this dense jungle of controllers around that tries to prevent that, but that's like a trap in itself. And the presentation layer, which in theory should be decoupled from the rest, usually also isn't. Like when you touch something, and yeah, it usually all falls apart. So that's kind of that. That also fell on our feet at Docker, which is the company where I'm contracting. So one of our main products is a website for chemicals, and we're the market leader in that category. So it's a relatively big thing, I would say. And for technical reasons, it was written, the component that we're working on, which is just the video and the chatting stuff, was written in Flash and then had to be ported to Haxe because Apple and Adobe and all of that. So this took forever. We had a huge JavaScript file at the end, which had just a bare core functionality in there and tons of bugs, and everybody hated us for it. So most of this happened before I actually joined. But yeah, so here we were stuck with this and needed to fix it somehow. So a lot of things went wrong, and not everything is about MVC or blah, blah, blah. I mean, tools are just tools. One of them was that actually getting real-time video streaming in the browser to work. Even today is tricky. 2 or 3 years ago, it was even worse. We were somewhat, or the team was somewhat strict and dogmatic about using all these nice enterprisey software patterns on all levels of abstractions. I mean, there's good reason to separate a few things through dependency injection, but when you have about 600 mappings in your code base for a video chat application, something is has gone wrong. And all of this was done in an attempt to just stay decoupled, be flexible, all of that, but actually the converse was true. When you wanted to add a simple button, you had to add 9 different files and probably touch about twice as many. So yeah, it was a bit problematic. But over the last year and a half, we didn't give up. And we took down the compile size from up there to about 1 megabyte of JavaScript. Took down the source code by a bit more than a half. Yeah, made the whole thing run a lot smoother. And I should say, during that time, we added like 80% of the features that we have now. And part of that was actually adopting some of the ideas and tools that I want to present to you now. So I guess the question with UI is, how would you do it if you could start all over again? And the answer is, you would actually have to start with the UI and then somehow build your way forward. Think from the user perspective, focus on that. Because if you somehow try to start anywhere else, it's like digging a tunnel from 2 ends, and then you just hope that you meet each other. And in other engineering disciplines, this is possible, but software engineering is a very young field, and usually you just wind up with a labyrinth in the mountain, and yeah, better start from one direction and keep going. And so one of the first libraries that really tried to solve that full force is React. I guess everybody heard of it. Somebody did not hear of React yet? Okay, very good. And so the basic idea was that UI is a function of state, as they call it. And so in React UI component, this is a simple one, looks like this. It has some state. In this case, it's just a variable that has a count. Then it has a render method that takes the state and produces some UI description from it. And then you can create the whole thing. And as you see, there's this click handler, for example, which calls a setState function that updates the state, and the component knows it has to redraw, and it will do. So what's different from classical views? One thing that's kind of the same. Usually, if you build, I don't know, for example, in OpenFL UI libraries, and you have your UI elements, they tend to have some properties. If they are set, then the thing is marked as invalidated, and at some later point, it all tries to converge into one central location to update the UI state so that it's not a total mess. But the thing where React goes one step further is you have the same code for the creation and for the update of the UI. Usually if you take, I don't know, Haxe UI, or if you take Flex or all these kind of things, they do have this beautiful descriptive XML markup to set the thing up. And maybe you can do some bindings, but if you need to do anything more complicated, adds children, removes them, swaps them around, then you have to write a lot of imperative code that lives in a world apart. And in React, you don't have this difference. So that's what makes it really declarative. You don't have to worry about this part. And the way that this works is that the render function does not actually create any UI. It's just a description of UI, if you will. And then these two descriptions get diffed, and only the difference gets applied to the underlying native UI layer, in this case, the DOM. And you can compose these things relatively well when it becomes more complex. I mean, just a button with a counter, you don't need a framework anyway. So let's say this thing is just an input field where you can put in a temperature. But you might want to have multiple of these that show the same temperature in different units. So what you then have to do is a pattern they call lifting state up. First, you have to externalize all the state. So here you see there's no state anymore, and everything comes through props. This is actually what you receive in the attributes when your parent composes you. And then you can say here's a converter. It has a basic state in Kelvin. And then you can have one input that converts this to Fahrenheit, presses in Fahrenheit, and then back from Fahrenheit to Kelvin whenever it changes. You do that for all the three, and basically, if you change the value in one input, it goes back to the parent updates its state, it re-renders. When re-rendering, it gives new props to its children, and the whole UI updates. So yeah, that's basically how you make a UI hierarchy work in React. A bit of a problem with that is that if you scale this up, you get big subtrees, and they update constantly because this component needs to talk to this component, and so they speak via their common ancestor, and everybody else somehow needs to get notified about their new set of data, which is the old one, but they still need to compare it to decide that they don't need to re-render. And the other thing is that the further you go to the root, the more business logic you find there that you don't actually want to have in your UI in the end, because you might want to have a completely different presentation for the same thing as established earlier. So to tackle that in React, you actually need something on top. React does not want to do that, which is, I think, an admirable decision, although maybe not the best. And there's, let's say, two hot contenders in the arena, and many variations of the two, of course. One is purely functional, it's called Redux, and the other one's object-oriented, it's called MobX. By the way, notice both have an X inside, so I think we're the coolest anyway. And so Redux is actually nothing super exciting. It has the concept of a reducer. Reducer is a function that takes some initial state and an action and produces a new state, which is different. It doesn't modify the state. From the action, it produces a new state. So basically, this is a state machine, but They have a different word for it. In some senses, it's just like a plain old small talk object. You just have something that receives messages and gets into a new state. But it sounds fancier when you use other words with X. And to use it becomes a bit complicated. Actually, instead of components, you just create functions that take some data, and then they produce some virtual DOM from it. And then you have to use some connect method from Redux and some map state to props, and you have to somehow connect the state, which is usually held in a store that you also need to create, with the component. And then it's super cool, but it's a lot of boilerplate, and I think it's one of the reasons Airbnb actually left React behind, if anybody read the series. So yeah, it's actually a nice pattern still. You should use it in moderation. That's well, this is my opinion. This is actually something that the creator Dan Abramovich is saying more and more. He's actually moved the most useful parts of Redux right into the React core, and you don't need to do all this other magic stuff. Although you can. I mean, everybody choose. Mobex is kind of I would say pragmatic alternative to that, where you don't have to sacrifice your firstborn son and the altar of purity. You just model your data as objects with plain classes, very old school, uncool. You decorate a bit of stuff, and also you have to decorate your components with an observer. That will actually make sure that when the thing renders, it tracks all the observable data that it consumes, and when those change, the view knows to update. But it's you just write pretty standard code, and the thing does magic. I mean, very declarative. But later came a whole bunch of full frameworks. I mean, there's more than I could list. Probably the most popular one right now, more popular than React, is Vue. And then there's one called Svelte, which is also which also functions like Vue by design, but implementation is different. They actually don't use virtual DOM for the thing. They actually have a very clever compiler that generates code that actually knows all the constant portions and only looks at the difference, and only basically it all compiles out to bindings and some very interesting flow control structures. There's Imba, which does also kind of the same thing. I think they were the first ones to have this kind of method, but to make matters more interesting, they have their own language also coming with it. And then there's Coconut, which is what we use at Docker, which I've created for our purposes, which is a pure Haxe library. And I'm going to talk about that a bit more. What I do want to point out is that React, if you haven't had the time to look at it, you should. There's a lot of stuff to hate about React, but it's one of those things that seem to be staying. I mean, and there's a lot of stuff that gets popular in the JavaScript community. Anybody remember CoffeeScript or stuff like that? But React is kind of a big deal. Already it's funded by Facebook. You have a really nice project with React Native that allows you to create native UIs with JavaScript, with hot reloading, all this kind of stuff. And I think just yesterday or the day before, Microsoft started publishing a React Native backend for Windows that they are maintaining. So it seems there is something where Facebook and Microsoft can agree. So it might stick around for a while. And like any self-respecting JavaScript library, it has decent hex bindings maintained by Philippe and Rudy, and I'm also trying to help them. So if anything else doesn't convince you, you have to look at that. And while all this virtual DOM stuff is a bit, what shall I say, not very easy on the memory, it's actually usually fast enough if you think a bit about what you do. So, for example, Battlefield 1 was actually has all this UI in React with MobX and a custom renderer that renders not into the DOM, but whatever they use to actually show their UI. So I guess the question is, what's this coconut thing? That's what I've been working on. So at this situation at Docker where everything was way too complex, how am I for time actually? Ah, cool. At the situation that we were in at Docker, we had all this complexity and a lot of frameworky stuff going on, and we thought, like, how do we get out of this? Oh yeah, let's add more cool framework stuff. So I've been tasked with writing the framework that solves our framework problems. So basically, I thought this is roughly what I'm getting into. Hence also the name Coconut. But here we are, 2.5 years later, and it turned out actually pretty well. It has grown into a relatively big set of libraries. Those all depend like on 10 other Tinkerbell libraries, but I won't bore you with the details. So there's Coconut Data, that's a bit like MobX. It allows you to create models, they are called, and you can annotate properties as being computed and observable as you put in MobX. It does a few other nice things. You can annotate them as loaded, then they can also deal with asynchronous computations and stuff like that, and they discard the ones that you don't need and cancel them for you and blah blah blah. So yeah, quite interesting stuff, and you can use it without the rest of Coconut. Actually, one of my colleagues integrated in some game engine, although it was a hobby, but another one rewrote his whole model layer of his. He has some kind of Jamba rhythm training app that's written with Feathers UI, I think, compiles via Air. It's on the App Store, and he rewrote the model layer with Coconut Data and doesn't use the rest. Okay, so on top of that is Coconut UI, which kind of knows what a view is, what the syntax for view is, how you define props, which those attributes, and how to handle states, and how to wire up everything. And then come on the backends. One is Coconut React. So you can actually use Coconut to target React. I will explain in a moment why that's not as bad as an idea as it might sound. And the other one is Coconut Diffing, which is a platform agnostic differ. And for it, there's one stable backend currently, that's VDOM, that actually renders into the DOM. There's one for OpenFL, which kind of is beginning to work, and one for Haxe UI that's kind of stuck, but yeah, it's going to be more soon. So the Reactant Operation is actually an important aspect, because what it means is when you target React with Coconut, you can use all React components within Coconut, and there's a lot of them on NPM. So there's quite a few that are actually worth using. And you can also, your React components become usable from your Coconut views become usable as plain React components. So other teams that don't want to use Haxe can actually use your UI code in an idiomatic way, I should say. So yeah, you have this vast ecosystem. Some of the, so for Material UI, for example, Rudy, who does a lot of stuff on the React front, has created externs. Those are also consumable by Coconut React. So it's really built to integrate. You can target React Native, which is so that's currently probably, if you want to do a native UI with Haxe on iOS, it's probably your best shot currently, until Ian gets around to make that work with Haxe UI. And so we also used that to switch to React at Docker in our team, because all our other front-end teams want to do it, and they're steadily inching forward to replace more and more UI with React. Maybe they're somewhere near 5 or 10% now. We leapt ahead, and to about 98% UI rendered with React, with yeah, some few hundred lines of code changed in a 50K code base. So everybody was a bit shocked when we overtook them in this manner. And it's really quite nice because we can just give them our views. We can use views from them. We don't do it as much as we probably should because, yeah, developers like to do everything from scratch anyway. But it's good to have the option. So yeah, so here you can see, I don't know if it works. So these two are, Kevin did this. Oh wait, Wi-Fi isn't working. Oh, it's just slow. Well, let's try this one. Okay, well the other one is stuck. Okay, it doesn't really matter. Like this is just a to-do list application written in Coconut, targeting Coconut React, and it runs really like a native UI. Ta-da! Yeah, and so nothing super exciting here, except that maybe it's possible to do with the same code base. And so to do MVC, to those who don't know, for UI programming is kind of the hello world. Create a to-do list with your framework, and then it's possible to look at that. So with Coconut VDOM, the whole thing comes out at 20 kilobytes minified. For reference, React and React DOM that you need for the DOM together are 120K, just like without the actual application. And Preact, which is mostly React compatible alternative to React, published a benchmark on how it's faster than React. So I took the benchmark and plugged in Coconut, and what came out is actually for small to-do lists, it's not that fast, but if you put in 5,000 to-do items, then Coconut begins to outscale the thing. Even more so on Internet Explorer. So yeah, it's a totally silly benchmark. Like if you have 5,000 to-dos, you should start using virtual lists to display them and all this kind of stuff. But it was only to, I actually wanted to know if the thing performed at all, and I was pretty happy to find that. But anyway, I mean, this is probably not a reason to choose any particular backend, I would say. The differences in Coconut VDOM is that you can actually mount real DOM into your VDOM directly and stuff like that, which React doesn't allow you to do. So if you get some, if you want to interface with other like legacy UI code, it's not that easy. And because we needed a gradual and smooth migration path, Docker, to actually move all our views from really old school, slap a bunch of HTML somewhere and then start querying it, blah, blah, blah. We wanted to move that to React-like style. And that with React was simply impossible at the time. We would have had to rewrite the whole thing at once. And so yeah, Coconut is kind of designed to not ask too much of you at the same time to get into. And I also, by talking, we find out that if you use Coconut with Preact and with React backends, then they perform about as fast or faster than the idiomatic solution that somebody else coded. Which is quite interesting because they also add a bit of overhead actually, because you have to call through two frameworks. But for obvious reasons, I think the virtual DOM renderer performs, yeah, maybe some 20% faster. Although it uses a bit more memory, interestingly. I think that's related to the fact that it uses enums for its internal data structure, and they are not that tightly packed. So, other backends. This is actually something I'm beginning to work on since recently. So there's an OpenFL thing I've been working on. Mostly it actually exists as a tutorial because people have been pinging me, hey, how do I create my own backend? So it's how do I? Yeah. So is it? Do I have this? So yeah, the Coconut diffing library actually has a README that explains like all the code that you need to put there and roughly what it means. And in the end, like a backend is maybe some 200 lines of code, 300, but it's really made to be easy to write. You might get better performance if you write your own differ and stuff like that, but you know, just to have a proof of concept and stuff like that. And I think yeah, here it is. So so let's first have a look at the source. So here we just, let me see. Yeah, okay. So this is actually OpenFL. So we have just this one native rect component that I made. All it does is draw a rectangle and a color, and I think it can have a click handler, if I'm not mistaken. And so there's this state, which is actually observable state, and Coconut does all the magic of wiring stuff up. And when you click on the what is this, red rectangle, then the state decreases, and then when you click on the green one, it increases, and that's all the code that you write. And lo and behold, super exciting, you get this very useful application. Yeah, I mean, it's done. So yeah, all programming is solved. You can go home. So yeah, but I'm definitely interested in pursuing that further and looking into maybe a Flixel integration. I'm also quite interested in is the feathers guy, is he here? Ah, there you go. Yeah, when Haxe Feathers UI becomes a thing, I definitely want to look into supporting that because it's a very, well, at least the Flash version is a very rich component kit. Haxe UI is also something I've been working on, but I'm a bit struggling keeping up with Ian, who is having ever greater ideas of how to implement the thing. But there seems to be a branch that's crystallizing now, and I think I'm gonna hook onto that. And then probably it seems like that because Mark was somebody who repeatedly asked me about how to write your own framework, and he uses both Heaps and Pixie for his games. So we might hear from him sometime soon, I hope. There's a backend. And as you might know, well, as Alex actually told, there's gonna be a JVM target for like a bytecode target, a direct one, that actually fixes a lot of bugs that currently exist in the Java generator. And with that, I hope to write a backend that actually targets Android natively. So you don't have to use React Native. You can just do the native thing. You can have roughly the same developer experience, but pump out native code. Again, shouldn't actually be that difficult. The biggest problem is that I don't know Android at all. So, yeah. And actually, whatever you might want. So these backends, I think, are relatively easy to create. But we all hang out on Jitter, and you can join if you want some help. If you want to try on your own, it's okay. I respect that. But we're there to help. Especially, I mean, XUI and Android is something that I see for myself that I might use that in production somehow. The rest, yeah, something might happen, but we'll see. So okay, let's look into some code, I guess. Is this oh yeah, that's right. So I think on localhost. Yeah. Okay, so this is the infamous to-do embassy app. Wait, did I build it already? Okay, I rebuilt. So one of the nice things is if you have, and I hope this is not broken because this is an experimental feature I've been working on, is that because you have all of this declarative code and there's not much side effects going on, there's a better chance to actually do hot reloading with the state that you have. I mean, just to make it clear, the application maintains its state. Like this is not in local storage or anything, and so you can do fun stuff. So you can do, for example, you can add a new state. I mean, the syntax is slightly different from React. Oh, let's make this false by default, and then we can say if and then these are my to-dos, and otherwise some to do. Okay, and we're gonna make this toggleable. Here, mine. Oh, mine is not mine. Let's hope this compiles. So these are some to-dos. Now they are my to-dos. This kind of stuff. So I can add in relatively interesting logic, shall I say? At runtime, I can move things around. So I can say, yeah, I actually want the header under the footer. Not that it makes sense, but you could do that. All this kind of stuff. Right now, the reloading works almost perfectly for views, not so much for models yet, because they have a bit more liberty about what they can do. But I think it's an interesting way forward, and the thing works the same for VDOM as it does for React. And at some point, if I figure out how to build open file projects with the compilation server, because this thing actually relies on the compilation server to just send the classes that changed, and it can retrieve the information from there. But once I figure that out, then it will be possible to actually live edit your UI on OpenFL, for example, if you do feathers or Haxe UI or whatever it is. In JavaScript for now. C++ coding will be, live code loading will be more interesting. Maybe with CPR this can be now. Yeah, have to look into that. So yeah, so that's one of the cooler things. Can, I guess, look a bit more into the code. So basically, as you can see, this is the basic just to-do list. It has a few to-dos and a filter. Oh, let's maybe put it that way, and let's put the footer back down. So the filter is actually yeah, this thing, which is displayed in the footer. This weird syntax comes from React. It means take all the attributes that footer expects, resolve them in the current scope, and then put them forward. It's a bit more complicated in Haxe than it is in React, because in Haxe it is type checked, meaning if you don't supply enough objects that supply all the properties, then it's actually going to tell you one is missing. Maybe I can, yeah, let's maybe just show that. I hope this doesn't explode. So if we say that we need a foo, then it's going to tell me object requires field foo, basically, right? Because it can't, from this it can't get it. So I'd have to do, for example, foo equals var, wow, and now it's again okay. So yeah, and as you see, I mean, there's all these rules. So for example, when there's no to-dos, then you don't want the footer there, for example, because point in having one with the filters. And this is simply achieved by if statement, and all the to-dos are rendered just by a for, so that there's no code there that somehow has to look at imperatively which ones did I render and add the ones that are missing, like the type of stuff that you would have in a list view if you implemented it yourself. You also don't have to actually use list views with item renderers. You would that if you need virtual lists or stuff like that, but if you just want to like iterate 20 items and put them into them dynamically, then you can use stuff like that. And so yeah, and in here, for example, so there's this thing that's to do item view, I guess. Yeah, okay. So yeah, this thing, for example, has a state that is editing, and when I double click, it goes into the editing state. So you see we're in a different branch. We have this input here where I can actually modify stuff, and when I when I blur, then editing goes back and the normal UI is restored. So this button comes back. This is not an input anymore, it's just text, and this checkbox reappears, and without me doing anything. So so yeah, I mean, this is exactly the same as in React. I'm sorry. And perhaps the one thing that sets it apart a bit from React itself is, for example, what it also does, tries to assist you, shall I say, if you say, I don't know, let's call it something. You want to have a priorities array, then for that you need to compile. And then it's going to tell you that arrays are not observable, because the problem is if you were to modify the array, which is just a raw plain data structure, then the framework has no way of figuring that out. If you know what you're doing, then you can skip these checks. Because that's like, what shall I say? Haxe's philosophy is try to be strict, but when it fails, it just lets you do the things, and I copied that because I think it's a nice behavior. So in some cases, you need to use data that the framework can't statically detect that it's observable, but you know what you're doing, you can do it. But most of the time, it really tries to prevent you from mistakenly rendering something mutable but non-observable. So it either has to be constant, or it has to be a model, or something. There's a whole range of stuff that's considered observable. You can look at that in the documentation. The thing has documentation. Lots of it, actually. Nobody reads it on my team. No, not true. So yeah, so these are some of the things it does. Oh, and there's one thing that's perhaps quite interesting. Just gonna demo that real quick. So there's this pattern. Oh, I'm gonna maybe just show that. I think I have some sample code with that. I have this. Yeah, okay. So if we, let's say, can I do that? Wait, no. What did I just do? All right. Okay. No, that's what I meant to do. We'll have it in a moment. Okay, so this is not terribly exciting. So actually, here we're using this lifting state up pattern. We have this button child component, which basically just doesn't get very specific state, just a bit of VDOM that should act as its label, and it has an on-click, and it has the same kind of communication with its parent, the same thing that we did with the temperature thingy. But the difference is kind of one button. If you see this is different casing. This is lowercase, so this is a plain HTML button that is actually rendered just within the container. And the other one is this button component view, whatever you want to call it. So the basic differences, and they are both wired each one against a state. So if you click this button, then the whole thing re-renders. But if you click this button, then the button does re-render because the state changed, but the parent doesn't, because the binding system that's underlying is intelligent enough to know that actually this data is only consumed by the child. So yeah, that's pretty cool. React can't do that, except when you use Coconut React. So yeah, this is the state of things. And I guess with that, I'm done talking about this. So, any questions? Yes, please. Do I know if anybody's working on a heaps backend? I don't know if anybody is actively doing that. I've actually looked into it myself. It wouldn't be that hard. Well, those two things are relatively orthogonal, I guess. I mean, what you could do, you could use DOM-Kit to create, let's call it native heaps views, and then you could drive them through Coconut for the more high-level stuff, for example. Because like DOM-Kit's markup also doesn't, it initializes the component, but after that you're kind of on your own. It doesn't even have bindings, if I'm not mistaken. Although, I mean, it's going to change. Like the library was like 3 months old, so knowing Nicolas, he hasn't even begun yet. Further questions? Okay, then let's have lunch. Oh. No, I think maybe that came out wrong. So what I do think is the separation between the business layer and the presentation layer is a very good idea. But you can implement it poorly, and you can interlace it with a lot of very complex rules that actually sabotage the whole idea, basically. Like with this classical MVC, with this controller layer that just has everything that you don't know where to put. It quickly escalates into, and Coconut actually does have just this distinction, but usually you don't need controllers, or very little controller-like code. Because usually what you do is you set stuff up, when you have anything controller-like, all it does is introduce the right objects to one another, the right models to one another, the right model to the right view, and then the rest is handled actually by the framework. It gives you certain guarantees. If it compiles, then it probably knows to observe the changes. There are few exceptions, that would checking those would probably cause more damage than harm. But usually, if it compiles, it can track the changes, and it does that for you, and it does that relatively clever. So it fetches up the redraws and stuff like that. But I mean, that's an implementation detail. It's even conceivable that because if you look at this, I mean, nothing in here says VDOM. Nothing in here says anything. This, you could write a backend, you can throw out all the layers underneath, and you can probably render this in an immediate mode UI or something, right? Because this is intent, mostly. I mean, it does have some details of the DOM API show up all over the place, because I didn't care to hide those away, but yeah. Please. Oh, okay. Yeah. So there's multiple ways. I mean, so long as you're targeting HTML, advice to you would be to first try to solve everything in CSS transitions and animations, because they run off of the main thread. Basically, it's all GPU and stuff like that. And the other thing that you do is, as they do in React, you create these kinds of higher order components. Let me just sketch out how they look, or maybe it's easier to show. Is this the right one? Of course, they don't have code examples. Okay. But basically, what you can, okay, I'm not gonna talk so much about the component. What you can do is roughly something like you have an animation, or let's call it animated. Yeah, let's call it an animated. It's a super not good name, but anyway. And you have a target value here, and this is something that is actually updated by the caller, so also by the framework, kind of. So this is some model, some property, for example. It's usually going to be something like that. And what you do, okay, let's maybe write it like this. Oh, sorry. And then what you do is in here on update, and here you're gonna put a function of progress. And you're gonna do something like, I don't know, smiley face. Or, no, let's call this value. Smiley face value. Smiley face, and then you're gonna say x equals value. So that, yes. Okay, so this is how you use these kinds of things. So you have it's called a higher order component. It basically, what it does is you give this something, and it calls this function to produce new rendering, and then inside it would look roughly something like this: animated extends view, and then you have an attribute. What is it? Target. Let's call it a float, and an attribute function render. No, what is it on update? So that that's the float, and it produces a render result. So this is what you call, and then you have a state, current, which is a float, which is probably gonna initialize to another number. And then what you do, there's this fancy hook. That's why you got to learn a bit about React or Coconut. Get derived state from attribute states, and then you're gonna say, oh sorry, let me think. No, actually, no, my bad. We don't need it in this case. So varret is, oh, okay. If current no, how do you compare with none? Something like this. So it's gonna be the target, and otherwise it's gonna be this the current, and then you call this updater with the current value, and then here you do a hex timer delay that says current equals, what should it say? I don't know, some linear interpolation between current and state. And then you return this thing. And so basically this is going to call, well, you probably, before you registered the callback, you wanna check if they are far enough apart to continue the animation. And you might even on complete do something which you call in the other case. But basically you have this higher order component and you just put in something and it's going to do that for you. And you can do this with you can also, yeah, even this can be basically using float. I don't know. This is probably bad, but and it's gonna have some default value. So you would actually create a view that can do this for you, and you would pass it a renderer function, and it's called until no reason to. Something of that kind. That's yeah. I don't remember anymore. This big React library that has like tons of those. I seem to have forgotten the name. Yes, please. So far, not many. Coconut Data actually has its CI and tests running on all of them. Well, not all of them. Java and C++. This Coconut OpenFL thing for now only works with JavaScript and Flash. Well, it probably also works with C++. It's possible, but I somehow bricked my C++ installation, so it doesn't currently build. But there's nothing platform specific in it. I mean, the compiler spits out the C++ code, and then the C++ compilation somehow fails. Well, no, it doesn't even start because some environmental variable is botched or something. Yeah. I need to take a computer. But yeah, I think in theory there's nothing, there's no reason why it wouldn't work on other platforms. I think, yeah, it should work. I've tried with, what is it, PyQt5, but I didn't actually understand how you update widgets once they are on screen. But again, this was me needing a computer course. So, lunch, yes. Thank you.